All right, people, welcome back. Okay, so today we're dealing with letter combinations of a phone number. This seems a very nice and interesting problem. So given a string containing digits from 2, 9 inclusive, return all possible letter combinations that the number could represent. Return the answer in any order. So why from 2, 9 inclusive and not 0 and 1? A mapping of digits to letters is given below. Note that 1 doesn't map to any letter. Okay, I see here. Okay, I see. So just from 2 to 9. And of course, each letter has each number has 3 letters. So basically, we have 3 options for each number. So given a string of numbers, can it just be considered 3 by 3 by 3? So isn't it just the number of numbers times 3? Could it be? No, sorry, it's not time 3. Absolutely. Or is it? Maybe actually. Maybe. So, sorry, if I just do, what's the input? Digits, okay. N is the length of digits. And then I just do return n times 3. Please don't tell me that it's so easy. No, it's wrong. Okay, so something I didn't understand. Oh, okay, I don't need to return. And by the way, this is incorrect because I returned 6. Well, the potential results were many more than that. Yeah, I absolutely. This in general is 3, because if I, for example, I have 2, 3, then it's like here I have 3 options, here I have 3 options, so it's 3 times 3 times 3 times 3. So it's not n times 3. It should be in principle the potential numbers that I can return are 3 to the n. Sorry, how do I do the power in Python? Let me just check the syntax. Oh, maybe I think it's that one. But of course, this is not what we're doing, but yeah, okay. So I just forgot the syntax. But this is not what we want to return. We want to return the expected number of, not the expected number of potential combinations, but actually an array of all the potential combinations. Okay, nice. Of course, we can do a triple for loop for each, because of the point is, if I just say, okay, so the first number is 2. So for each letter in 2, and then the second number is 3. For each letter in 3, and then I just basically do, I create the string and then I add it. This is, of course, requires 2 iteration, and it's gonna increment a lot in the number of iterations I do. Of course, the output is basically equivalent to the number of iterations I do. So I don't know if this is actually the best way to approach it. So of course I can write down that the length of the digits is n, and then from n I know how many for loop I have to do. So let me think a bit. If I have A, B, C, D, E, F, the point is n can be arbitrary, so it doesn't limit to the sum of all numbers. If I have a string of length 50, that is a big problem, because of course the number of iterations are going to be, as we said, 3 to the power of n. So a lot of possible iterations. And that's the problem. Like I see that the complexity seems to be this independently of the algorithm I create. Or is it? Okay, so my idea is then to use a sequence of for loops. So my idea is we have to return an output. This output we can call combinations. And then combination is an array. Is an array of a number of strings. Okay. So what we can do is to write down that combination is basically a letter like A times, and then the length of each string is going to be n. Okay. So you basically have a 8n time, and then you want this string to be replicated 3 to the power of n times. This is basically the final array, of course, filled with just a. Do you see what I mean? Okay, so with that, we have all the of course, we have to store in these possible combinations the real values, but we have in our memory the output. Okay, and then what we can do is the following. So for I in range n, and then we start to iterate. So we start, for example, from the first letter. And we say something like, yeah, I'm quite sure we have to... Okay, it's very difficult to explain, but my idea is to basically go on with I and put basically as first letter or second or third our letters according to a scaling of n according to I. Okay, so the idea is, for example, let's say that we have 3 to the power of n possible combinations. Then the first time, I basically divide this number by n minus, n by 3 to the power of I. To the power of I plus 1. Trust me, it makes sense. It makes sense. I plus 1. And these are going to be the cuts. Now, of course, in the first case, there will be a cut each letter. Yes. Each letter there will be a cut. Then the length of the cut basically says that I set the count to 0. And then every time I write down that combinations letter I has to be changed to letter. Okay, here we have to define a dictionary. Okay, so let's first, to be honest, I think this doesn't work, but let's first write down the dictionary. So the dictionary is going to be something like letters is going to be something like, let's define the dictionary, which is going to be 2 is ABC. 3 is DEF. 4 is GHI. 5 is JKL. 6 is MNO. And then 7 is PQRS. 8 is TUV. And 9 is WXYZ. So this is the dictionary. Okay. Now, given this dictionary, I want to take it to account with this algorithm, but I don't know if this is the best way to approach it. Okay, no, this doesn't work, but I still feel that something based on the fact that each time we do thrice more works. I didn't have actually the chance to explain this in a very clear way. It was actually a bit confused in my mind, that is why. So let's start from scratch and let's see if we can do something a bit more elegant. So my idea is the following. We iterate through the digits, so in digits, of course. So if our string is like 23, we say the first digit is 2. And then of course we would write down A, B, and C. And then what we do is to go to the second digit and we say, okay, given this digit, I go through my A, B, and C, and for any of that, I append the first letter, D. So I'm going to have AD, BD, CD. Then I do with the second letter, and then I do with the F with the third letter. And then I have 9 possible combinations. If then I add a 4, I will have 27 combinations, and I will continue like that. So my idea is, if I simply say 4 digit in digits, okay, first I have to define the combinations. Let's define then to nothing, okay? And nothing is a list, okay? So we have no combination. Now, for digit in digits, the first digit is gonna be, let's say, 2. For letter in letters digit, let's call it then triplet. My current triplet is letters digit. So for letter in triplet, what I want to do, for each string in my combination, I want to append a new string which is equal to the previous string plus the current letter. So maybe here we write that for combination in combinations, what we want to do is to say I append to combinations combination plus letter. But then this is going to create, so better to, okay, this creates problem because I'm adding something to combination while combinations is in a for loop. So better to create a temporary list, and we append to temporary the combination, something like that. And then we return combinations, of course, after the for loop here. We say that combinations is equal to the temporary, and then we return. What about this? No, invalid syntax. JKL, yes, of course, this is just a syntax error. Here, what's the problem? 2. Two is a problem, 2 is the key. Yeah, but of course the key must be written as a string. So this is why. I think this is the problem. I'm quite sure of that. Let me see. So it was the problem, but we still have wrong as a result. Why do we get an empty list here? Maybe because there is no iteration, so maybe we need to add an empty. Yeah, okay, so the problem was that without anything in here, there was basically no for loop, never. So it went on and on. If you instead add an empty string, the first string, which is actually empty, And this is exactly what you want to return in case we have basically no digit. Then the for loop starts and then everything goes fine. So this is the result. And if I submit, whoa, okay. Guys, it goes. Okay. I'm actually very satisfied with that because I really feel this is the way it is intended to be solved. So I'm actually very, very satisfied. Yeah, so I think we can consider this problem to be solved. Let me check if there is any follow-up question. No, okay. So now the complexity. Now the point is, I already know which will be the total number of iteration. It will be 3 to the n because we have to write 3 to the n times. We have to write them in the array. So it is pretty non-linear in terms of time complexity, but I think this is the best thing we can do anyway, because this is like we need to do at least an iteration for each value we store in the array. And not even 3, because this is 4 here and here. So it may even end up in being 4 to the n. And here, since we are doing a combination of strings, this of course may require n. So actually the worst time complexity is 4 to the n times n, which is not great actually. So yes, in terms of time complexity, not great, but this is the way the problem I think it is intended to be solved. So I think we can say we solved it. So thank you very much guys for watching this video, and see you in the next episode.